Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of second derivative test. So as per the problem, determine the critical points for the function and use the second derivative test to decide if the point is a local maximum, local minimum or neither. So the given function is y equals x cubed minus 6x squared minus 15x plus 10. So this is a polynomial function. Now we can find the critical points for this function by finding the derivative of this function and setting it equal to 0 to find the x values. So the first step is to find the derivative of this function. So y prime equals, we have to use power rule to find the derivative of the terms. So for x cubed, the derivative will be 3x squared. So as per the power rule, we move the exponent to the front and subtract 1 from the exponent. Now in the second term, negative 6 is the coefficient of the term, so it stays as it is, and the derivative of x squared is 2x. Then negative 15 is the coefficient of the third term, so it stays as it is, and the derivative of x is 1. And 10 is a constant, so its derivative is equal to 0. Now we can set the derivative equal to 0. So we set y prime equal to 0 on the left side, and we can simplify the expression on the right side. We get 3x squared, and we can do 6 times 2, which is 12, and 15 times 1 is 15, and the 0 goes away. Now we have to solve this equation to find the critical numbers. Now this is a quadratic equation, so we can solve it by factoring. So the first step is to do common factoring. We can factor out a 3 from all 3 terms on the right side. So now we have a simple trinomial in the parentheses, and we can use the sum and product rule to factor this expression. So we have to find two numbers whose sum is negative 4 and product is negative 5. And the numbers will be negative 5 and 1. So we can write the factored form as 0 equals 3. So this is the factored form. Now we can set each factor equal to 0 and solve for x. So in the first case, we can isolate x by adding 5 to both sides. So the 5's on the left side cancel each other out. So we get x equals 5. So this is the first critical number. Now we can solve the second case. So we can subtract 1 from both sides. So the ones on the left side get cancelled out. So we get x equals negative 1. So this is the second critical number. Now to find the critical point, we have to sub in these x values one by one in the given function and then find the corresponding y values. So let's start with x equals 5. So we can do it here. So y equals 5 cubed minus 6 times 5 squared minus 15 times 5 plus 10. Now we can Evaluate this expression. So 5 cube is equal to 125 minus 5 square is 25 and 25 times 6 is 150. Then minus 15 times 5 is 75 and then plus 10. So now we can combine all of these numbers and I get negative 90. So the first critical number is 5 comma negative 90, the critical point, sorry. So this is the first critical point. Now we can sub in x as negative 1 in the given function. So y equals negative 1 cube minus 6 times negative 1 square minus 15 times negative 1 plus 10. Now we can evaluate this expression. So negative 1 cube is negative 1 and negative 1 square is positive 1 and negative 6 times 1 is negative 6. Negative 15 times negative 1 is positive 15 plus 10. And now we can combine all of these numbers. So we get positive 18. So the second critical point is negative 1, 18. So we have answered the first part in which we have to determine the critical points for the function. Now we have to use the second derivative test to decide if the point is a local maximum, local minimum, or neither. So the first step is to find the second derivative of the given function. So we'll use the y prime equation to find y double prime. So y prime is equal to, so I'll write it again. So we got y prime as 3x squared minus 12x minus 15. So now we have to find the derivative of this y prime, which will give us y double prime equals, so we have to use the power rule. So in the first term, so 3 is the coefficient, so it will stay as it is, and the derivative of x squared is 2x. And in the second term, negative 12 is the coefficient, so it will stay as it is, and the derivative of x is 1. And negative 15 is a constant, so its derivative is 0. Now we can simplify this expression. Minus 12. Now we have to sub in the x values from the critical points one by one in this y double prime to see if y double prime is less than 0 or greater than 0. So let's start with x equals 5. So y double prime 5 minus 12. So y double prime 6 times 5 is 30 and 30 minus 12 is 18. So in this case, y double prime is greater than 0. So that means there is a local minimum at the critical point 5, negative 90. Now we can do the analysis for the other critical point in which the x value is negative 1. So we'll sub in x as negative 1 in y double prime equation. So now we can simplify this expression. So 6 times negative 1 is negative 6 and negative 6 minus 12 is negative 18. So y double prime is less than 0. That means there is a local maximum at the other critical point, which is negative 118. So this should be the final answer for the second part of this question. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.